S11, and today we're looking at describing techniques used to manage soil fertility, including conservation tillage, maintenance of soil organic matter or carbon, crop rotations, organic fertilizers, inorganic fertilizers, and pasture lay phase. So first of all, it'd be good if you wrote a definition of soil fertility. Soil fertility is basically the ability of soils to grow or to sustain agricultural production. So again, soil fertility is the ability of soil to sustain agricultural production. And so it mostly relates to nutrients, but also relates to soil structure and various other things. But the focus here really is on nutrients. So thanks also to Ruby for letting me use her sheet here. So we need to look at each of these different things separately. There's 6 of them. And here we have a picture of 2 different types of fertilizer. So we've got an organic fertilizer on the left and an inorganic fertilizer on the right. The one on the left is called Charlie Carp, and it's basically carp, the fish, which are a pest in river systems in Australia. And so they're harvested and taken out of the river and killed and crushed up, and they become a really good quality fertilizer. And obviously it's organic, because organic means it comes from living things. On the other hand, over here we have superphosphate, which is a man-made fertilizer, which comes basically from crude oil, and it's very high in phosphorus, and it's enormously high in phosphorus and low in other nutrients. But remember, phosphorus is one of the 3 key main nutrients or macronutrients that plants need. So this is kind of, let's say, an unsustainable practice, but it's going to increase the nutrient level in your soil very quickly. All right, so let's have a look at these different practices and how they help manage soil fertility. So first of all, conservation tillage. So conservation tillage is basically referring to minimum tillage or zero tillage, and you're basically ploughing the soil less, because remember, tillage equals ploughing. So by doing that, you are having machinery go over less, and you're also leaving plants on the surface to break down in the soil and improving the fertility that way. It also helps reduce soil erosion, and the way that we lose nutrients from soil is one of the main ways is through erosion, whether it be wind or water. And if you're not ploughing as much, there's going to be more ground cover, and more ground cover is going to prevent wind or water eroding the soil. It also helps improve the soil structure by not disturbing the soil and allowing infiltration of water and nutrients. And remember, soil fertility is related to both nutrients and structure, and it also helps improve soil moisture, because there's something on the surface which helps maintain water in the soil and stop it from drying out as quickly. On the other hand, you're going to use more chemicals. So often when you're doing conservation tillage, you'll spray herbicides such as Roundup afterwards to kill the remnants of a crop instead of actually ploughing. And so the downside is that there's going to be more chemicals used. The second one, maintenance of soil organic matter. Now remember, soil organic matter is primarily carbon, which and also remember, carbon is the main component in living things. So every living thing has carbon in it. And so ways that we can maintain soil organic carbon or increase the soil organic matter is by leaving crops, slash the remains of crops and leave it on the surface to decay. And that also, once that breaks down, that forms organic matter. And remember, most of the nutrients in the soil are in the top couple of centimeters, top 1 or 2 centimeters. You have about 80 or 90% of the nutrients in soil in that top couple of centimeters. So positives here are it increases soil biodiversity and microorganisms. The more organic matter you have, the more life you have in the soil and more organisms. And you'll remember from an earlier dot point on nitrogen cycle that microorganisms really are the things that do all of the nitrogen cycle, that transfer nitrogen from one form to another. So it's really important that you have lots of healthy microorganisms in your soil. Increasing soil carbon and nutrient levels also decreases your need for inorganic fertilizers, which are unsustainable in the long term. And you also get decreased erosion by having more ground cover over the soil as well. So there's a bit of overlap between these two here, between conservation tillage and which leads to maintenance of soil organic matter. The negative side is it can decrease productivity of an enterprise by taking up time and money to actually implement these things that we mentioned over here. The next one is crop rotations. So this involves changing the type of a crop grown in one area on a regular basis. So you might have a legume and then a wheat or oats or something else that you're going to, a bit of a cash crop, and then you might leave it in fallow for a while and then maybe another legume, etc. So you know about crop rotations already. And so it ensures that one particular nutrient doesn't get depleted more than others, because if you use crop after crop after crop of the same thing, like wheat, the nutrients, for example, if it uses a high amount of nitrogen, there's going to be a low amount of nitrogen in the soil. Whereas if you put legumes in every now and then, every few rotations, then you are going to get an increase in nitrogen due to the legumes. It can also help eliminate pests, which decreases chemical resistance, because when you have a monoculture and you plant lots of crops, or a wheat after year, any insect that is that likes wheat is going to be able to build up and remain high levels of that insect. Whereas if you change to another crop like lucerne or something like that, any pest of wheat will not be able to survive on anything in the meantime. The downside is if you have a fallow period in your crop rotation, you're not going to make any money. So it's a bit of a long-term sustainable practice to have crop rotations, but some years you won't make any money off it. So organic fertilizers are related to inorganic fertilizers. One of them is from living things, so they contain carbon, hydrogen, oxygen, and it's come from something that's living, whereas inorganic fertilizers are man-made. And I've already given you examples up here of Charlie Carp, which has got a range of macro and micronutrients in it, and superphosphate, which is just primarily phosphorus, which is one of the macronutrients that plants need. So just quickly, basically organic fertilizers increase both the macro and micronutrients because it's got a range, and it generally doesn't pollute waterways because it's available over a longer period of time. So the negative here is that they take a longer period of time to break down and become available to the plants, whereas inorganic fertilizers down here are man-made, and they are generally made from crude oil or something like that. So they're obviously not great for the environment, but they become available to the plants very quickly. So as soon as you put them on there in a form that the plant can access straight away, there doesn't need to be any cycling of the nutrients. On the other hand, inorganic fertilizers can cause things like eutrophication because they give you such a large hit of a certain nutrient such as phosphorus in superphosphate. It can be harmful to waterways, and if you get eutrophication, you get algae growing on the surface and less air getting into the water body, and therefore the fish and other things in the waterway dying. The last one here, pasture lay phase. So this is basically having a crop rotation, but particularly you're having grass or green manure crop planted in the rest period, then ploughed and grazed into soil to increase fertility. So what you're trying to do in the pasture lay phase, lay just meaning kind of off period, when you plant something to increase the nutrients within your crop rotation. So you're increasing the organic matter and increasing macro and micronutrients, but during that time the pasture is not productive. So the 2016 question here, past HSC question, describe two techniques the farmer can use to improve or maintain soil organic matter. First one is conservation tillage, minimum or zero till. So you could utilize less plowing or none with the use of direct drilling of seeds into the soil surface. This maintains stubble from a previous crop, example wheat, on the surface, which after breaking down over time increases soil organic matter, or OM for organic matter, and carbon levels. So green manuring, a second one here, number 2. It's good to put these numbers here so it's clear. Planting a crop that will not be harvested but is ploughed back into the soil before seeding. Once this breaks down, it provides increased organic matter levels. 2015 multiple choice question, the long-term fertility of sandy soils is best maintained by conserving organic matter, because organic matter provides most of the nutrients in a soil. 2015 question here, explain how conservation tillage assists in maintaining soil fertility. Conservation tillage is a system that creates a sustainable soil environment for growing a crop that conserves soil water and energy resources, mainly through the reduction of intense cultivations and retention of plant residue. Maintenance of ground cover reduces the erosion of nutrient-rich topsoil and reduces cultivation, improves soil structure, allowing for more effective infiltration of water and nutrients. High levels of water and nutrients allows plants to grow at an optimum rate, increasing soil, or as a result of increased soil fertility. The last question here from 2012, compare techniques used to manage the nutrient level of soils in the mid-20th century to those currently used. So the mid-20th century is the kind of 1900s. It's not asking about indigenous practices. It is asking about early European practices compared with what we use currently today. So here we have nutrient levels refers to soil fertility, which means the ability of the soil to sustain agricultural plant growth. So I've just given a definition there. Early 1900 techniques such as widespread use of inorganic fertilizers such as superphosphate have been used to quickly and significantly improve or increase soil nutrient levels and hence fertility, in this case phosphorus. However, it also leads to problems such as nutrient leaching, which means it moving down through the soil and out of the plant's reach, and eutrophication of waterways. Positively though, it does provide required nutrients to plants at exactly the phase of plant growth required. Modern sustainable practices such as the use of crop rotations with legumes help improve long-term levels of soil nutrients, particularly nitrogen, over a longer period, particularly available to the next crop. While this is the more sustainable and less detrimental to waterways, it takes longer to obtain.